you can see, this is the presentation about limited work in progress for developers. And it will be not lots of slides, and it will be mostly like hands-on. And in the first place, I'd like to explain what I mean by limited work in progress. I personally found out about it from Kanban boards. That's like the simplest example we can have. So lots of teams, they have boards like this one where you have stages of development and you move cards left to right. So for example, if I'm a developer and I finished a card, I move it from development column to testing. And the idea of limited work in progress in this setting is that you can impose limits on each column. So like at the top, there are numbers now 3, 5, 3. So it means if I'm a developer and I finished the card and I moved it, as you can see, from development to testing, I cannot actually do it because there is a limit at the top. It says 3, so I cannot move this card. I have to maybe move it back, and the idea is that maybe I should go and help people test what we have. And that's limited work in progress, and that's how you do Kanban. That's like not how you do Kanban, but it's one of the main things about Kanban, that you have some constraints. And there is a bigger idea which might not be very intuitive, and one book I read years ago, so I don't claim to be expert on the topic, but that's a theory of constraints. And this book, The Goal, which is kind of an interesting book because it's a business novel, so it tells a story of a person, but it also kind of teaches you something about theory of constraints. And I think the idea, like the main idea, is that you need to have a system view of the whole process, what you're trying to achieve, rather than try and optimize tiny bits. And taking these ideas and maybe bringing them to actual like lower level, not lower level, but just software development, that's the thing which sounds interesting to me, at least. So I'll kind of show it, applying these kind of ideas of adding constraints by doing a couple of demos, TDD with auto-revert, which will revert all the code every 1 minute, and then test and commit and revert workflow, which is the different workflow, which I'll explain later. And I'll use IntelliJ IDEA for the demos in Kotlin. And I'll use this plugin called Limited Work in Progress. I wrote it, but the plugin itself is not like the point of presentation. It's more kind of about ideas, how things work. And finally, to make the problem a bit simpler, I'll use just FizzBuzzWoof coding task. Coding problem, if you haven't heard about it, it's a simple kind of interviewing task. It has these rules. You're given a number, and if it's divisible by 3, then your function should print fizz. If it's divisible by 5, it's buzz. If it's divisible by 7, it's woof. And all the combinations, so 15 will be fizzbuzz. And otherwise, it's the number. So for example, 8, it will be just 8. It's quite simple problem, but the whole point is not to solve the problem, but like how you solve it. That's why like deliberately simplistic problem. And so part 1 will be test-driven development with auto-revert and change size limit, which like limits the amount of changes you can do at a time. To be fair, to like mention this, auto-revert was originally, I think, called baby steps. At least I think that's where I heard about this technique. And as far as I could track, this is it was proposed by Adi Balbaka, and that's the blog post. So that's the history of it. And now I'll just switch to IntelliJ IDEA. So here is IntelliJ IDEA. It's in presentation mode. And I have here a couple pop-ups. These are from the Limited Work in Progress plugin. So I'll collapse this project view. So as soon as I change some code, you can see, like make any changes, you can see there is a timer which counts down. So let's write something simple. Since it's TDD, I'll write a test. So I'll say 1 should equal 2. And obviously we expect that to fail. So I can see now that we expected 2, but it was 1. And we can also see there is a change size at the bottom. So it says we have 2 lines changed. That's like 2 lines, 1 import, one line with assertion, and the maximum is 5, which is quite low, but I'm not going to change it now. It's kind of a bit late. So if I go above the change size limit, so we now have 6 lines changed, but 5 is the limit. Like you can see this notification, and it says, "Look, there are too many changes. Please, like, consider splitting up your changes." So I'll ignore this for now. And as you can guess, if when the timer reaches 0, all the code will be gone. So in a second. So now we get notification that everything was reverted. So that's the constraint. So let's try and do fizzbuzzwoof with this. So we want fizzbuzzwoof function, which takes a number. And for example, for 1, it should return 1. So let's create this function and I'll move it out. So if I run it now, it should fail because obviously it just throws an exception right now. The to-do function in Kotlin is a function which throws an exception. And the simplest thing we can do using like the baby steps technique from test-driven development is to return 1, which is just hard-coded value. This should pass now, and I can now go and commit. So I'll write a very simple commit message, just because there isn't much time to write lots of commit messages. But also you'll see just like how this workflow works really. So like the next thing to try may be 2, and that's the simplest increment I can get from here. So let's compile this and run, see how it fails. Doesn't work that well when computer gets slow because with short timers. But the whole idea is really like, I'm not suggesting that you should use this constraint. It's more like to experiment with this constraint and kind of learn something from it. So this test failed. You can see expected 1 was 2. So the simplest thing to make it pass is to convert M to string. That should work. There isn't much time already, so I'll speculate and already put 2 as a commit message in the commit dialog. There is also implicit constraint that I don't want to commit code with failing tests. So I just managed to commit, I think. So maybe when compilation is a bit slow, that's not ideal, but that's not ideal. I'm already making quite small steps, but in reality, the whole idea is that the pressure from the timer will make you make much smaller steps than you would otherwise. So in this case, the simplest thing I can do is just return fizz again. So hopefully this will pass, and then I can add 2 more assertions. For example, I can add 4 and 5. So this test passed now, and I can try and squeeze in buzz, something like this. So if I run the test now, just to see, I can see I'm probably not going to make it. So I'll just use this bit cheating technique. And so yeah, the test failed, but I know I commented out this line, and then it was kind of still okay to commit. So like I'm rerunning test once again, and it all worked. And the problem kind of partially was that I did a few things at the time. If you remember, I did first 1, then 2, and then I tried to do fizz, 4, and buzz. So as soon as, with this kind of techniques, as soon as you start doing too many things, it becomes much harder to avoid reverts, and you end up cheating a bit. So that's like a sign. So maybe you can take in smaller baby steps. And the original constraint, it was used at code retreats and with the intention to learn and with the intention to actually do TDD with much smaller steps. So I'll add buzz now as a comment message. So now there are things like if we add 6 is divisible, so it should also be 6 is divisible, so it should also be fizz. So I'll run this. It fails. So at this point, it can also become a bit kind of boring, because if I run tests, see them fail, make a small modification and save them, then it's like, what's the meaning of these commit messages, because they become too small. So I could like put ... and then I can say commit. And I personally, when using it, ended up, for example, if I go for 7, then it's going to be too many things. Go for 7, then maybe 8, 9. Up to 9 should be okay. And this should still pass. Then you can, I added this action, commit without dialogue. And here I bound it to just Command S, so it's a bit like save button. Save as in like you used to have files, so this test pass I can press commit without dialogue, which will just commit, so I don't have these changes anymore. So in a way, it's a bit like a save button when it was common to not have files saved. And the original reason for this, I think, was that hard drives were quite slow and writing was expensive and so on. So now it's gone, at least in like an IntelliJ from like 10 years at least, like definitely more. I wasn't using this feature. So now like kind of commit becomes a new save button in some way. So here, let's do, well, I didn't run it really. So now let's see 10, and there will be a few more things, like there is definitely woof and all the combinations, which can be quite big. I'll do 5. And I think I'll try and take bigger steps really quick. So this is still running. It's passed now. I'll save this. Do combination 3 by 5, which is 15. This should be fuse bars. And then there will be combination. Maybe can add 11 just to be sure to have more things. So it will look something like these bars. It will be 2 things here, 3 and 5. Around this, it should pass now. And there will be combinations of woof, which is not ideal, but I'll keep the same structure. So I'll save this, and I guess this mentioned in the chat, yes, it's definitely lots of kind of nonsense commits, but then like there is a separate question of what is the point of commits and what are you trying to do with them. So one thing which is possible to do with these commits is to go into the history and kind of squash them, for example, because if this is all just implementation of FizzBuzz woof, then it could be just like one big commit, if that's your preference. And one of the ideas around this is that these commits, like you can keep them local and then squash later, but then you know that you're doing really the minimal modification you can. Or you can also have an option to share it with other people, and this way it becomes the smallest possible unit of interaction with other people. So like similar to the next thing I'm going to show, this is like the overall idea was, what if you could have Google Docs, but with writing code? And if you can manage, so the problem with Google Docs when everyone's editing everything is that you never know if the whole thing even compiles, and you don't know if it works, and you don't know if the test will pass. So with this thing, you create in the smallest possible shareable unit of work. And if you share it with the other people, then it can be the tightest possible integration. So it will be like, so this could be buzzwoof, made in combinations. So it will be 3, 5, 7, and I hope I get this right. And I hope I'll have enough time to finish there. This is 3, 5, 7, fizz buzzwoof. This is fizzwoof. I hope it's going to be right. So going back to the comment that these are nonsense commits, like absolutely yes. And the question is oh, there is bus as well. The question is why use and keep in commit history. This will be more interesting now, because if I try and commit this, it will tell me that I cannot, and I can force it. think it says it was reverted, but it was. I'm still a bit confused. I think it wasn't reverted, and like that's another point with all the change size notification, all these constraints with this plugin. So the plugin is not really designed to force you to do anything. It's more about kind of creating constraints to help you learn from them, not to force you to do something that you don't want to do. So it's like, doesn't get in your way. You can always turn it off. It's just in the setting. You can always undo things, to be fair. There is local history, which has everything that you typed. So this was like not the nicest implementation of this buzzword. And I actually wasn't doing a proper TDD, you can argue, because I completely missed the refactoring step. So I'll do a bit of refactoring. Like one thing I can do now is to convert this if else expression into if else statement into an expression. In Kotlin, if else is an expression. So if I added else's on all lines. So now I can do this refactoring of lift and return. So there are multiple returns on each line. And now if I do this refactoring, there is only one return outside. So it's like one big expression. And then I can convert this into when, which is in Kotlin is like similar to switch in Java, but it's also an expression. And I convert this whole thing into a slightly different form. So this pass should pass the test. And I convert this to expression body, and I can kind of drop the type. Maybe it's a bit more idiomatic in Kotlin, so I'll call this refactoring and I'll commit that. This is a bit better, but it's still kind of combinatorial explosion. So if we added one more bird, like quicks, then like, you know, we'll have to like copy all these lines again pretty much. So that's not ideal. And another technique, which kind of I was drawn to using auto-revert on real code, was to, like the problem with auto-revert is that you would normally be shocked that like, oh, I'm under pressure to type something and I don't know if it even compiles. And this is true. Like the thing is that you can type anything as long as it doesn't break your existing system, right? So I can define a function called fees, which takes an int, and it may be like the simple thing, like returns an empty string. This function is not used. I can just commit it anyway, right? Then I can say if n is like basically repeating condition. If n is divisible by 3, I can do fees. Otherwise, it's an empty string. It's not used. I can run tests, but I know it's not used, so I can do it like that. Then maybe when I start using the function, that becomes more interesting. So now like I formatted it a bit, and I can try and like the idea is to plug this function. So I'll save this code so I don't have any changes. You can plug it right here and concatenate with the when. So this will start failing because we output fees, but then I can just delete fees from the output of when. And this way you can do refactoring in small steps. So this passed, so I can just save the test. And the idea, if it went wrong, at least like I would not lose all the code. Then obviously I can go and do the same with buzz. So it will be 5. And with roof, which is going to be 7. So yeah, and I'll just save this code. So if something goes wrong later, then I don't care too much. So let me do it buzz. And interestingly, it failed because it was a typo. But I still have now time to do that, so that should be fine. Could also plug roof because there are 30 seconds just to do that. I'll run this again as well. And yeah, another example to not go to find, not to delete all these lines, because it can be a bit more tricky sometimes than it seems. So it's just all about doing minimal transformations. So these tests pass, so I'll just save this and I'll enforce commit. We had 4 seconds left. I think like these lines can go, so that will be fine. This test will work, but we cannot delete these lines. So yeah, this worked, and I'll save this. I think if we delete, for example, 7, there will be some failing tests, because if one of these things matched, then we don't want to convert number to a string. Now, like, this test fails, and it says it was with 7. And what we could do, we could wrap all of this concatenation into parents. So it's an expression. We can say if it's empty, then we return empty string, and this empty string becomes empty string. So this is no op now. I just did it in a very small step by replacing the last else with empty string. This worked, so I can do delete when and just run this. It will be the final thing, and I still have like 10 seconds. So yeah, I'll save it now. And just to show the history of what it looks like, it will not look very nice, obviously. So yeah, you can see in the beginning there was like 1, 2 fees, then I switched to dots, and there are lots of commits. And so yeah, in theory, I could have squashed all this. I can go and like squash all of this into one bigger commit and then push it if that's a problem. So that was the demo of auto-revert and TDD and auto-revert. Wasn't maybe the purest form of TDD because it was supposed to be like revs, failing test, fixing test, and refactoring, and I did like a big refactoring at the end. So there's a mini retro. There is, if you try it and you like stress from the timer, like that's absolutely normal. And the idea is like not to get rid of stress and not to like force yourself to be comfortable, but like change the way you work so you kind of get less stress, and it kind of becomes timer disappears. Then I definitely in some cases rushed to commit because the compiler was slow, but like in real world it's rushed because, oh, I don't have time. And in some cases doing it, I think if I make smaller changes, it just becomes kind of invisible that I'm doing this thing. So that's like reflecting on what happened and thinking about auto-revert timeout. If there was a timeout, which is like 10 years or like 12 months or 6 months, you probably would never notice it. In a way, we already have this kind of timeouts. Like, you know, if you forgot your code on the computer for 20 years, like probably you don't care about it and your hardware will degrade. But it's like days, weeks, probably also most people won't care. Minutes and hours, it's a bit more interesting. This is like what you can actually try. And if you go to extreme, like minutes and hours is what you can try to learn from it. And if you go to extreme, you can go to seconds, then it's like, it is kind of impossible to change anything. And this is where you can argue if you could make safe refactorings really quick, like your IDE or editor could transform code in a safe way and commit it straight away, then, and it could do it under a second, then it's kind of doable. But this is just a thought experiment, so like don't take this too seriously. Then there's a change size limit. Similarly, if you have like 1 million lines change size limit, you will never get this notification pretty much. Like 10,000 lines, probably, unless you're doing big refactorings, nobody will notice it. 100 lines is like what I used on real project as a reminder for myself, like maybe I'm doing too many things, but it's just a suggestion, right? Sometimes you need to change more. And 1 line, similarly, it's like, how can you even do it with 1 line? So maybe then if you kind of swap it to not change size, but maybe actions and ID instead of 1 line, then it will be more realistic, but yeah. There is also a separate question, which is not an easy question. How do you even measure change size in lines? Because it's not always obvious. Without going into details, it's like ambiguous in some cases, because if you deleted 100 lines, did you delete them? Or if you like, maybe you moved them, it's more complicated. And plus all the empty lines in the meaning of a line is questionable. So there's another like thing which is kind of interesting. If you're doing TDD by the book, then it is a work in progress limiting technique, because you like in the first stage, you're not allowed to modify production code. You just write in the failing test. Then you're like not allowed to write more tests and so on. So you can interpret it as limiting technique. And just to reiterate it, this constraint's not to make you feel bad or anything, even though this might happen, but these are constraints for you, like for us to learn from it and to be better in some way, to improve our ways of working. So that was the part 1, and moving on to part 2, which is about test and commit or revert. It's also known as TCI. So the rules are for it are that you cannot commit without running tests. If the tests pass, changes are committed straight away, or if the tests fail, all the changes are reverted straight away. So it was popularized by Kandalov like a couple of years ago, and it was the idea, Udman and some other guy, I forgot his name, they came up at a workshop with Kandalov. So it's a bit like an arcade game, like that's maybe a fair analogy. If you play an arcade game and you got past like a save point, then if your character dies, then you go back to the save point. So it's a similar idea in some way for TCI. And I'll just demo it again then. So I'll go back to IntelliJ. I'll go to settings. This is the plugins. I'll disable change size watchdog. I'll disable auto-revert, and I'll enable TCI module component. You can straight away see there are options like on the past task, there is like it's an open question. What do you want to do? Do you want to commit and uncommit, commit and push, or just open a dialogue? And if you command commit, or if you commit, what kind of message do you want to use? Here I'm using last commit, but there is no right answer, as you can imagine. So the first thing we can do is just delete everything and kind of do it again, but maybe a bit quicker. So the first thing, we just deleted the code. As you can see, there is no timer anymore, so no more time pressure for me. So I'll write a commit message called TCR. Now, if I try and commit it, the plugin tells me the commit was canceled. Please run test to commit. And again, there is a link to like work around it, but I won't. So just to demo it, I'll run the tests. And because there are no assertions, they pass, and everything is just committed straight away. So I don't really need to like do anything. Now, so yeah, that was the first rule. That we can, the first rule was that we cannot commit without tests. Then as soon as you run them and they pass, everything's committed. And the third rule is that if they fail, so if I do something like that, and I run tests, all the code will be gone. So yeah, now everything is reverted. So moving on to fizzbuzzwoof, if we want one, fizzbuzzwoof 1, it should be equal 1. So I can go and create this function. The difference is that you cannot really do TDD with TCI. I cannot run this thing. I mean, I can, but I shouldn't because it will fail and revert everything. So I have to get it right the first time I run it. So it has to be correct. And again, it's a bit like a stressful thing, especially on real big projects, of like, what if it's all wrong? And similar to auto-reverts, the answer is like, yes, this can be painful, but the thing is that if you take small steps, you won't have too much to lose, and that's kind of okay. Or maybe you can find ways to make even smaller steps than you think, which are already small. So if you think like something, this is the minimal change I can make, maybe there is something smaller. So because you cannot do TDD, there are like different ways around it. So if I really want to, so that's one of the suggestions I had, is like to negate all your assertions. In this way you can kind of, you can say, actually I want to say fizzbuzzwoof 3 should not equal 3. And then I kind of delete negation. Then I go and say if n equals 3, return fizz. So that's like one way to attempt to do TDD. Just write the wrong thing first. Oh, that was wrong. I should have said it should not equal fizz. I got this wrong. So the idea was like, shouldn't equal fizz, this will pass. And then if n equals 3, then it returns fizz. So then another obvious idea, so hopefully this works. Then another idea is to write some assertions or something like that. So do bars, need to write implementation, write bars, and this is 5. So if I run this and it passes, hopefully it does, then everything is committed, but I don't know if this assertion actually worked. For example, I can like break the assertion, add something at the end, then it should fail now. And it should revert the code and should show me there. Oh, similarly, I can go and modify code and see if this breaks, then everything is reverted. So in a way, it's a kind of manual mutation testing. So that's another way to attempt to doing TDD without actually, like with TCI. So also with TCI, you're not really, if you follow the rules, you don't have to kind of, you don't have to write test first at all. So I can just go and do this, right? Just all of these things can do them. As long as they pass tests, I'm good to go. So that's why I think some people say, okay, that's fine, but this is a fad. TCI is not great. And then like I literally am just writing tests after this. We can do 14 for woof, that will work. So there are also, obviously, let's just write all the combinations. So there will be 15 as well, which is going to be fees plus. There will be also fees plus woof, which is all of these 3 by 5 by 7. There will be 10, doing it out of order, which is a dangerous thing to do. There was also 11, I remember. These bars, should be bars woof. And so literally, this is the example of like I already wrote so many insertions. Like I don't want to go and delete them. Well, maybe I also want 8. And I also want fees, which is 9. I don't want to lose assertions, but if I run them and they fail, they're all going to be gone. So now I'm under pressure to get all the combinations right, which again, I'm just going to copy paste a few times and then refactor. So there will be 5, 7, which is going to be buzz woof, is going to be fees woof, and there will be all of 3. Okay. The fees buzz woof. Double check 3, 5, 7, 3, 7 fees woof 7. And this is again an example of what not to do, or like maybe I'll be punished for that now. So hopefully not. And I was. So now I have to do it again, but then maybe slower. There is another aspect of it, is that could actually, like one thing is that if I look at the stack trace now, I don't necessarily have the code which failed. And that's another interesting thing, because when like you doing a normal development and your assertion fails, then your options are like, there are a few options. Like one thing people do is just play the computer in their head and basically look at the code and see what it's going to do, and then infer, like by simulating computer actions in their head, then see, this is the result I expect versus this is how execution works in my head. This is not going to work here because I don't have source code anymore. So I can try and look at the stack trace, but again, like usually the stack trace takes you back to the point in the code where it fails, and I don't have it here. So maybe I should take just smaller steps and do it. So there was fees bus woof, which was a combination of all these 3. And there was 3. So nothing really stopped me from just running this quickly. And that would save me a couple lines. And I got this wrong. At this point, I'll just like cheat and try and figure out why it's going on. So expected proof, that's fine, obviously. So this was fine. Keep this. Then there will be 10, which is bus. So that should just work out of the box. And will be, definitely will be fees woof, which is 3 by 5. is for the case. Maybe it's easier to modify this condition. Oh, not fees booth, fees bus. And that's going to be fees bus. And there is only like 2 more. Oh, wow. I'll cheat once again. So it was 3 by 7, fees roof. That's definitely fees roof. Oh, this is not going to work. Too many mistakes for small code, for a small piece of code. And so similar thing, 3 by 5, fees bars. And there will be bus roof as well. So this is a bit kind of repetitive and maybe not the most exciting thing. Bus roof. So if writing code is like maybe like not the most standard thing we use in TCI, refactoring works much better. And so because it's like I mentioned, it's a bit like an arcade game. So you can add else's in front of all ifs and run the test. If this breaks, we will be taken back to the safe place. So you can do again the same transformations. So it's going to be when, then it can be converted to expression function, the expression body of the function. And this time I'll try a slightly different refactoring. So in particular, I'll try and extract these functions. So say it's like is bus, or like bus. So just transforming basically conditions, not the whole expression. So a few of them, so it's like bus, no, that was fees. Should rename this to fees. This is bus. I got it wrong. This is bus. And I'm doing it in like in a bulk because this is ID transformation and I would hope that it works correctly. So let me run the tests now. The truth is that even though it's like supposed to be safe transformation, it might not be, and there are bugs and IDs and so on. So this worked, so that was kind of fine, but it's still kind of not ideal, this whole representation. So we can try and similar thing, saying if fees of n, then it's going to be some kind of string. Otherwise, it's going to be an empty string. So the conditions do something like that. Fees, if fees, then we return string fees, otherwise empty string. But it's kind of a big step. Maybe that's a simple thing to just minimize the failure. And we can even go like further and maybe add all of them in the beginning. So it's like saying bus, then empty in the roof. So these are knobs, and this is a way to kind of extend the code without really breaking it. The problem might be this, like this introduces a performance, like degraded performance that can be a performance bug then that can break systems. But otherwise, you could even like release this kind of changes. So to continue, let me add just fees here and remove fees from the output. So this should work. So it means that these two should also work. So I'll do bus and roof, and all of this can go away basically. It is similar to the code we had before. And if you remember, there was a theme that some of these lines were important, so can delete all of these lines, but we need these lines, otherwise it's not gonna work. So if I delete with, we'll be taken back to the last working state of the code. So yeah, so we need one of these lines, and again, what we can do, can wrap all of these functions with their parents, make it one expression. And then you can say if empty, maybe this looks like a big step, we can just run this no op if empty, which doesn't do anything. And then we can kind of swap this empty string with this expression over here. So like a copy, cut and paste it. And I swapped two expressions. So now if none of these conditions are true, we're converting number to a string. And obviously this when is now redundant, so we can delete this. That's kind of like how you would do TCR, FizzBuzz with TCR. I'm just reformatting this a bit, so maybe it looks a bit nicer to me. So just these three conditions, and if empty, it converts everything to string. So this is the demo of TCR with FizzBuzz with. Let's switch back to slides. So as a mini retro, it's not really compatible with TDD. There are a few workarounds. You cannot debug. It's good for refactoring. Like there are some problems, like on bigger projects, if compilation takes a really long time, then it's a bit more difficult. Then there is definitely questions like what's going on with commit messages, because they're all the same. You can maybe retrospectively go and change them. Or maybe we kind of, why do we need commit messages again? Like to have a history of the project. So maybe we should write it somewhere and keep commits as the smallest unit of integration between different people in like almost real time. Right? And then there is a question there is a question about commit or commit and push. That's something I mentioned before, that like you can commit locally and then transform all the history. But then, yeah, or you can choose to use the commits as the smallest shareable unit of work. So there are some answers to all of these questions. Like there are TCR variants, so you can find blog posts and read about them. You can also watch videos on YouTube by Kentberg, how he does TCR in Python. And if you want a more complicated example, I did a regex matcher with Jordan Stewart. You can find it on YouTube. And this is kind of it for the second part. And third part is not going to be very long. It's more kind of an overview. So the main message here is that like this was just a demo, and when you watch something, I did it as a live coding so that it's a bit more realistic and maybe it like makes more sense, or that you can imagine doing it yourself, but ultimately you should try it yourself. And so it's quite simple. So change size you can do via Git hook. So like, yeah, you can just write your own small shell script and try it. You don't need to use this plugin, the plugin I was using. For auto-revert, you can use any timer really on your phone. Pomodoro timer is a standard thing. You have to be a bit more vigilant, and it's easy to negotiate with yourself, but nevertheless, it's easy. And for TCR, you can roll out your own shell script or find one online, or obviously use the plugin. So that's another option. So yeah, definitely try some of these things, maybe on a small problem first. And as a conclusion, I will just have questions. So one of the things which I already mentioned is like, what is the point of commit messages really? If they are to tell the history of the project, then maybe like, do they really capture all the history? Because there are lots of decisions which are made to not use particular technology, and it's hard to express it in a commit. So maybe there should be still like a separate file with all the architectural files, or like multiple files with architectural decisions. Or maybe it should be a thing like architectural decision record, when somewhere you can say this is a block of the project, and whenever we made a big decision, we kind of write down the context, organizational context, and so on. So maybe these decisions could also be tied to some commits. So it's not always one-to-one mapping. So yeah, I'm just, for myself, I'm asking, what is the point of commit messages, especially for my own small projects? Do I really benefit from them that much? So again, what's the point of commits? Is this, yeah, so it's just a technology and we can use it for different purposes. I also think that maybe version control systems, lots of the design decisions they were made in a different era when like hard drives were slower, the whole development pace was slow, the internet wasn't that widespread. So maybe it's time kind of to rethink what we're doing with all this technology. I think lots of concepts that we used of like commits have to be in a certain way. They all kind of come from the past to some extent. Maybe it's time to rethink. And then like, if this is the case and we want to use commits for like as a smallest integrational unit between people on the team, maybe it's the new like internet era save button. So there are no more save icons because people don't understand floppy disk, but so maybe that's the commit button is the new save button then. And talking about all the commits, it's all about like pushing changes, sharing it with the world, but then what about receiving changes automatically? To be fair, in Git, as soon as you push, you will also update, so that's kind of fine, but it would be nice maybe to have even tighter thing that even if you haven't pushed, but somebody changed the same thing you changing and it will cause a conflict, maybe you should be told like straight away before either of you are trying to push. That would be cool, but I don't remember like any discussions about it. And it also seems that there is lots of like focus on branching strategies, pull requests, and it's fine in certain contexts. I understand people probably need that, but it's like so much energy spent on this and not much energy spent on thinking, could we maybe solve other problems so we never need feature branches? So integration between all people is so like fast and smooth that like we can do ultimate CI with working on one code, which is of good quality, and we can continuously push and update basically on a single branch, which is just the code, which is the best state of the code we can get. And this is now, if we find a problem, we just fix this quickly. So that would be ultimate continuous integration, because all the branching strategies, this is a discontinuous integration. So there are many problems with like these workflows. One is just compilation speed can be slow, as you have seen. It's not ideal, and this is not the slowest compilation. And there are different approaches. You can interpret this as you cannot use these techniques are bad because well, they don't work. Or you can say, oh, maybe we should improve our tools, our tools and make our tools faster. And I find it also frustrating that it kind of seems that compilation speed in the last 20 years, like from my experience as a developer, didn't really get anywhere. So computers are way more powerful, everything's more powerful, but compilation is still super slow. Not super slow, but on big projects, it's like not instant by any means. So yeah, and like on a larger scale though, everything I said was like developer centric, but ultimately it's all about delivering value to people, or like making something happen so that people change their behavior in real world. So maybe we should focus on this rather than on like, I finished my coding. Maybe there should be more feedback loops from production and stack traces integrated to the IDE. So we actually wait for feature to start to be used to get actual metrics before we move on to the next feature. Maybe work in progress should be completely end to end. We wrote this line and it's used in production on 100% of users of this website. Maybe that's a thing. So yeah, more feedback loops in IDE editor would be nice. So everything I showed is on this GitHub. In this GitHub repo, there are a few more links to the books I mentioned and different talks and ideas. So this is it. Thank you for watching.